All right, let's build some visualizations with AI. This is a demo I've been doing kind of on the road, DataOps Days and a few others. And I think it's really cool because it just shows some of the capabilities of LLMs today, if I've got my data contextualized and what I can do with it. So to start this demo, I'm going to do something I typically don't do, which is to show some slides. Because I think I'm going to move kind of fast through this, not go through the nitty gritty of everything that I've done. So I think a high level conceptual of what I'm going to do will help. So I've got a factory, fertilizer plant, and over on the left is my equipment. So I've got a crusher, drum dryer, granulator, mixer. This is all on a single line, right? And this is making fertilizer. I've got a factory in Portland, Maine, where I'm located, and for systems it has an OPC server, it has Kepware, and it has AVEVA Pi for historical data. So in this case, we want both real-time data and historical data. So I'm going to use HighByte to contextualize those and think about them like I do over here in terms of my equipment and the data models. And then I'm going to expose that data over MCP. So I'm going to use Claude Code in this case, but you can use any agent to give it access to that data so it can browse the machines and understand the data shape and access the data. And what I'm going to tell Claude to do is I actually want it to build an artifact, which is an HTML page, to visualize this data. And I want that page to be able to pull live data from HighByte using our REST data server. So a lot of people do demos with building dashboards, static dashboards off of AI or MCP tools. That's been done. It's a little more novel to make those dashboards update by calling an API. But HTML and JavaScript runs in the browser. There's no reason that that can't be used to call an API, and I'll kind of show you how that works. At the very tail end, I'm going to branch off and basically point what we've built after it's working to a second HighByte instance that's in a different factory in Albany. And that has two different systems, Ignition and QuestDB, but I'm going to implement the same REST data services. So it's the same API. So what I can do is take this HTML page, point it basically to different data sources and get the same capabilities. And that's part of the beauty of Industrial DataOps is that abstraction. I'm going to do that without restoring the data, recategorizing. I'm literally just going to pass it through and contextualize it in the same shape. Okay. Out of slides into working products. So in here, I've got both factories implemented in the same HighByte just to save me time, so I'm not jumping tabs here. We'll focus on the Portland one first, and I've gone through all of these are mapped to instances in HighByte that are then mapped to the OPC tags in Kepware. So I've done all that mapping already, such that when I read this stuff in the namespace, I can see the nice contextualized data. The other thing I've done is I've implemented a few MCP services, just three. So just three to make this work. One is to browse machines. So this goes through the factory and says, hey, what machines are in there, the drum dryer, crusher, etc. I want to be able to read the current state of a machine. So I'm going to pass you a machine identifier. I'm going to read back the state of the crusher, drum dryer. And then I want to be able to read the history for a machine. In this case, I'm just going to pull back the last 5 minutes in 5-second intervals. So just these three tools. And if you looked at these tools, they're linked down to pipelines. Every one of these pipelines, the three that I have that facilitate those tools, I can either route it through Portland or Albany. And remember, Portland is Kepware and Pi. Albany is Ignition and QuestDB. So at the end, I'm going to switch this and you'll see what it does. All right, I think that's it for the setup. And what I'm going to do now is launch Claude Code. And I've got a big set of instructions that we're not going to read through that I'm going to give Claude. And the one other thing I've done is I've connected Claude to HighByte. So if you look down here, I have those three tools that are exposed to Claude. And I'm going to paste this now because it's going to take a little bit for Claude to chew through this. And while it's going, we'll just talk about what it's going to do. So I got pretty descriptive in here. In general, I don't think you need to be so much. Oh, Claude's going to ponder, so this might not even work. We'll see what happens. But if you look at these instructions, basically I'm saying, hey, you got to set MCP tools about the factory. I want you to use those tools to basically discover what's in the factory and the shape of that data and access both the historical and the current data to know the data shapes. Once you know that, for all the machines that are in there, I want you to go build what I'm calling an HMI or visualization on top of that data. So I want you to use some poetic license and build the HMI however you think based on the data shape. So you expect the crusher and drum dryer to show up in there. And then this is the important part. I'm instructing it specifically to go access the REST data server endpoints that are in HighByte that expose that same data. So here I'm saying post to this endpoint with this payload to pull back a specific machine. And if you go into HighByte under our settings, under REST data server that I have enabled, we have a Swagger doc that explains this. Looks like we might not get through this demo. We'll see what happens. It looks like it's struggling. In fact, it's struggling so bad that I think we're just going to kill it and see if we can get on a different cluster of GPUs. It should be a lot faster than that. I've said it before, but anytime you, especially Claude, is very fairly unreliable. I'm using Claude because it's easy to demo with. It's typically easy to use. Um, but you don't need to, right? You could use any agent that has access to MCP tools. Use Gemini, ChatGPT, you name it. So let's try that again. See if it chews through it. What I was showing you here is this is the REST data server. So I could probably give the agent access to this Swagger doc, and it could figure out how to do that without me instructing it, send a post with this payload. Like it could figure that out. In this case, though, I'm just trying to be super descriptive because I want it to work in the demo. Here we go. This is looking better. Maybe. Let's condense that. So, oh man, look at that. That's absolute garbage. I don't know what it's doing. Okay, we're going to third time's the charm, right? The model's acting faster, but it just made a curl request out to an API. It did not use any of the MCP tools, which is weird because they're enabled. Okay, we got it to work. So it's chewing away. So the first thing it did is what we'd expect. It'd go call browse machines. So it's calling that MCP tool. The next thing it's going to do is go get the current value of each one of the machines. And it's going to, so this is what it's doing to figure out what does the crusher look like? What does the drum dryer look like? What data does it provide? After this, it should come up and get the historical data, and it looks like it's starting to chew really slow on the token response. So this is, it typically only gets the first one because all the data shape of the current value and historic value is the same. The difference is historical data is like an array of values, each with a timestamp. So it kind of infers that based on that. And now it's doing the hard part, which is it's actually building the HTML page. So we got there. It took 3 attempts. So while this is chewing, I'm going to pull that off to the left. We're going to use the one this generates, but I'll show you other examples of what it created in previous runs. So it generated this HTML page, and I'm just opening this HTML in the browser. And if you go to configure, you'll see I'm configuring a base URL and then a bearer token to authenticate with the API. And that token happens to be the same token as I'm using over MCP in this case. But you can see once I set that up, it's putting that in browser local storage, and then it's showing the data. And we know this is reaching out to HighByte because we can go to the network tab and you can see each one of the requests come through. This is saying, give me the data for the drum dryer, and here's the response, and then it just shows the data. So the LLM isn't inferring any of the data. It built a static artifact, and it's just showing what's there, and it's using a polling mechanism every 5 seconds to go poll the REST data server with live values, which is pretty cool. And you can see this is coming through, and we can map this back and look at this is what's coming from the OPC server. This one was funny because the one I'm showing you here, and hopefully the one it's generating now doesn't do the same thing. I wasn't explicit about generating a chart, so it actually just put all the historical data in a table. So this is making an historical request, but it's putting it in a table, which is not that interesting. All right, it looks like it just finished, so I'm going to come back. And it created the artifact, right? So it's creating the HTML, and I'm not as interested in looking at it in. It's an interesting loading icon. I'm going to save that HTML as an HTML doc, so I'll call it HMI final.html. We'll save it on the desktop, and then we'll open that one and see what it did in real time. This is dangerous. It doesn't look that bad. So this should be updating every 5 seconds. So there's an update. If we view historical, okay, it built a better chart. Sometimes it doesn't update the chart very well, so we'll see. Oh, looks like it's doing the updates pretty well here. Interestingly, it decided to split up these measurements across 2 because you can see the scale here, the X scale. So it made the inference that the scales were off by enough that it decided to split these up into 2 charts on its own, right? I didn't tell it to do that. And you can see this is historical data coming from Pi. Every time I go and request it. And it has all the machines. And I did tell it if one of the machines was an alarm to show that, but I don't. Let's go see if it's going to do it. So I have a simulated data here, and what I can do is put it in a bad state, not BAF state, bad state, and we'll see it's hit or miss on this one. So it didn't do it. There was another one. Oops, it needs the bearer token. 1 second. And you can see these are all generations of it, right? And they're all like a little different. This one shows the alarm stopped. Let me just make sure. Oh, you know what? I might not be linked into the correct. 1 second. Let's go to the MCP tools. Read current machine. I'm going through the wrong one. So I was showing you Albany on current data and not. So I was doing Ignition and QuestDB, but I didn't know the difference, right? Because I've created the abstraction, I'm providing the data back the same way, but I'm going to switch it back to Pi, and that's the stuff that should have the alarm off it. And we'll see the alarm's showing up in this one, but in the one that we generated here, it didn't put. So that's hit or miss. I instructed it to put an alarm flag if the crusher was an alarm, but it clearly didn't do that. But anyway, I could instruct it to come back and try to fix that. But this is pretty cool, right? Like with human language, I instructed it with very minimal access to the data, right? Just like you can browse, read, or write what's in here, go build a screen, and it did it. And it also fed it with historical data. What's really cool about this, and I already just kind of demoed it because I guess when I initially set this up, this was wrong. I can come in and switch this from a system that was Kepware and Pi, right, to Ignition and QuestDB, two entirely different technologies. Let me go back to QuestDB. And if you actually went and looked in here under MCP, I have internal tools, and this is the pipeline that's doing the data munging to convert the QuestDB format to basically what Pi looks like. So to the agent or to the application here, there's no difference, right? You're just looking at a different data set. But because I've created that abstraction with DataOps, this REST data server interface is the same across the plants, even though the underlying technology is different. I can carry this application across plants, which is pretty cool. What's the point of all this? The point of all this is if you use Industrial DataOps to contextualize your data, the ability to build applications on top of that data is going to, if not just today, like in the future, is going to be done with human language, and it's going to be done by the people that are your process experts that are communicating with tools like this or whatever to build whatever end application they want. That's a world. Do I think like a whole new class of vendors are going to come up that do this? No, I think the existing HMI SCADA vendors are going to adopt tools to be able to build these artifacts in their platforms using natural language. And I think the challenge then is going to be not necessarily access to data, but how do we manage all these applications that people are building on the factory floor to do the niche things and the important things that they need to do because they're process experts and they know their process, and now they can use natural language to get the data in the format or perform whatever application they need on the data. They don't need to go down to Bob, who's the Pi system specialist, to get a screen created. They can literally create that screen using natural language themselves and interact with the technology. That's a world where the number of applications blows up into the thousands, and your challenge, if you're in this domain of data ops or trying to manage this, is how do I manage all these applications? How do we find the applications that drive the most value and replicate those across the enterprise? It's going to be a really interesting world, right? Where suddenly data access isn't the challenge. It's managing all the stuff people are creating on top of the data. Not necessarily a bad thing. But something to think about. But everything I showed you, you can do today. So give it a try. If you have any issues, feel free to reach out and give it a shot.